Welcome to another edition of Math for Nodes. In this edition, we are going to show that the number square root of 2 can be expressed as a continued fraction 1 plus 1 by 2 plus 1 by 2 plus, and this continues ad infinitum. Now, how do we write a number in terms of a continued fraction? So, the process is as follows. We know that root 2 is 1.414, etc. So, this is a number which is larger than 1 but less than 2. So, we take out this 1. So, we look at a1 to be equal to 1 and consider root 2 minus 1, which is 0.414. So, this is a number between 0 and 1. Now, we take the reciprocal of this. So, we consider 1 by root 2 minus 1, and simple rationalization gives us that this is root 2 plus 1 divided by 2 minus 1. So, this is just root 2 plus 1, which is 2.414. Again, we take out the integral part and keep only the fractional part. So, in this case, we get the integral part we represent as a2, and we get a2 is equal to 2, and we now deal with root 2 plus 1 minus 2, which is again root 2 minus 1. Now, again we will take the reciprocal of this remainder, which again turns out to be root 2 plus 1, giving us a3 is equal to 2, and the remainder root 2 minus 1. And this process will continue. So, all subsequent terms a4, a5, etc. will all be equal. And we will be able to construct the continued fraction 1 plus 1 by 2 plus 1 by 2 plus 1 by 2, etc. as the continued fraction representation of root 2. Now, since there is an infinite process involved, we should be careful in this, and therefore let us see if we can convince ourselves that the limiting quantity that we got in this manner ultimately gives us root 2. For that, let us call this quantity as x. So, x minus 1 is 1 by 2 plus 1 by 2 plus 1 by 2 plus, etc. adding. So, if this infinite continued fraction converges, we would expect that this would be equal to 1 by 2 plus x minus 1. So, note that this part is actually x minus 1. So, therefore, we should have in the limit x minus 1 is equal to 1 by 2 plus x minus, and that simplifies to x minus 1 is equal to 1 by x plus 1, and that gives us x square minus 1 is equal to 1, or x square is equal to 2. That implies x is equal to square root of 2 because this quantity is positive. So, we can convince ourselves that the quantity that we derived through the process that we just saw actually leads to the number root 2. So, in general, what is the process that we follow to sum up? If you have to derive the continued fraction of this number x, let a1 be the greatest integer less than or equal to x, and r1 is the fractional part of x. Now, we look at a2, which is the greatest integer less than equal to 1 by r1. Remember that r1 lies between 0 and 1. So, a2 is the greatest integer less than or equal to 1 by r1. If r1 is 0, the process stops. Otherwise, we will have r2 as 1 by r1 minus a3. a3 would be the greatest integer less than equal to 1 by r2, and r3 will be 1 by r2 minus a4 would be greatest integer less than equal to 1 by R3 and R4 will be 1 by R3 minus A4. So we can see that in general our AN will be 1 by Rn minus 1 and Rn will be 1 by Rn minus 1 minus An. If at any stage Rn becomes 0, the process stops. The resulting process would give us the continued fraction representation of x, which is A1 plus 1 by A2 plus 1 by A3 plus 1 by A4 plus. So that is the way in which, given any real number x, we can represent that number as a continued fraction. It's a good point to stop. Thank you.